what we've looked at this up to this point was a single output SO system that we're working with. Now we're going to look at the MIMO, just briefly at the MIMO robust servo mechanism. So the single output approach, even though we have multiple outputs, we can choose to use a single output approach. That is, we only track one signal out of the multiple signals that are available. Okay, so having multiple outputs actually can be helpful if you're actually working with the observer. Okay, so the more signals you measure, generally speaking, you will get a better observer. Okay, more robust observer. So that is actually helpful, but in this case, we're only tracking one signal with one reference. So that's the single output approach. So the plant itself could have multiple inputs. That's not an issue. We've seen we can use the place command to get a state feedback gain for multiple inputs, so that's not an issue. So here we basically, even though we have multiple outputs, we're only using this approach to track one signal. The full multi-output approach, that is when I have multiple outputs, has a problem. There are challenges associated with this problem, so we're not going to go into it in great detail because since you have multiple outputs, the outputs are combinations of the states, and depending on how the states are set up, you can have problems with references and their tracking. So for example, if I have two outputs, one signal is, let's say, some signal Y, and let's say the second signal that's coming out is the velocity of the first signal, in which case these two signals are closely related. So if you choose to track two signals, one of which is some signal and the other is not the derivative of the first signal, then you're going to have problems because there's no way you can get the derivative to track something that's not the derivative and so forth. So as you can see, there are some issues with tracking signals, and so we're not going to pursue this approach here. Okay, so I mean, you can actually derive it and develop it in such a way that you can work with it, but it's just beyond the scope of what we're trying to talk about here. So that's why we're only going to talk briefly about this. And so how to do the single input approach. Okay, so we can still take k tilde to place the eigenvalues of a tilde plus b tilde k tilde as before, and we can use L to place the eigenvalues of a minus LC in the full order observer, but we would basically form the robust servo using only Y1, for example, as the output of the system. That is, it looks like this. Okay, so Y1 is used. The full Y can be used in forming the observer, but only Y1 is used. And so that's the approach that we could take. That's one approach. That is, we're only trying to track one signal here. So this is the tracking and disturbance rejection problems.